So in this video we're going to integrate the reciprocal of x squared times the square root of x squared minus 4, and our parameters of integration are 4 over root 2 and 4 over root 3. So with this integral set up with this square root term in here, best way forward is some sort of trigonometric substitution. Now you can use a hyperbolic one or a couple of different options for a U-substitution. Now there is 3 that I've tried already, and the one I'm going to show you today is this one. So I've got x equals 2 cosecant u. That's the one I'm going to show you right now. Now the other 2, I'm going to let you have a go at those on your own. You can put a link in the description. Tell me which ones you prefer. So that there, I've chosen that one because I want this 2, because when I square it, I want a 4 to go with this 4 as well. So that will work good. And then hopefully inside here, I'll get some sort of trig identity. So let's progress with this one and see where it takes us. So I need to find x squared because that's in there. So I'm going to do that. So x squared equals 4 cosec squared u. So that's my x squared. And then as I'm doing a u substitution, I'm going to go from the x into the u. I also need to find the derivative of this value for x. So my dx equals, now if you check the link below, I've got how we got the value of this derivative by using first principles. But the result is here. I'm going to write it down for you. Minus 2 cotangent u cosecant u. So that's my derivative, and then I need my du at the end. So that's going to be my substitution. Let's just squeeze that u in there a little bit neater if we can. Okay, so that's my substitution for my x to my y, to my u. Now I need to deal with my parameters. So I've got x at 4 over root 2 and 4 over root 3. So I now need to find out what my u is. So let's take care of that. So when x is 4 over root 2, let's deal with that one first. So I've got 4 over root 2, that equals 2 cosecant u, and then I need to solve for cosecant u, I need to solve for the u. So now what can I do here? Well, I can divide straight away both sides by 2, and cosecant of u, I know that that is the reciprocal of the sine function. So that equals 2 over sine u. So I'm going to divide by 2 both sides and introduce this reciprocal here. So then divide both sides by 2. I've then got 2 over root 2 equals 1 over sine u. So then if I multiply both sides by sine of u and then divide both sides by this, I will get sine of u equals 1 over 2 over root 2. So what I can do with that, just bring the root 2 onto the top. So that is root 2 over 2. And then I know from there, if sine of u is root 2 over 2, my principal value for my u is going to be pi over 4. So u equals pi over 4. So that's in the case for this one. So that's quite a lot of work to do there. So now we need to do this one. So this time in the case when x equals 4 over root 3. So that's going to be 2 cosecant u. So I'm going to do exactly the same as I did on this example. Divide both sides by 2 and then use this reciprocal. So then I've got 2 over root 3 equals 1 over sine u. So then if I do the same here, I'm going to get sine of u is the reciprocal of that. That's what I've got here. So I'll do the same here. So sine of u equals root 3 over 2. Then I know my principal value for sine of u to be root 3 over 2. That's going to give me pi over 3. So that's u equals pi over 3. Okay. So now I've got all my building blocks ready to substitute all that into u. So I've not done anything yet. All I've done is got all my building blocks. So let's take care of this. So still doing the integral. 4 over root 2. When x is 4 over root 2, u is pi over 4. So I've got pi over 4. 4 over root 3, I've got u is pi over 3. Okay, so now let's deal with this. So my numerator, I've got 1, that's nothing to do there. So then my dx is minus 2 cotangent u cosecant u du. So I'll just write that in my numerator. So quite a bit to fit in there. Minus 2 cotangent u cosecant u, and I'll put my du there at the side. So that takes care of my numerator. Now we need to deal with this. So x squared is that. So that's 4 cosecant squared u. And then I want the square root of that minus 4. So the same thing again, but this time minus 4. So now you can see why I chose x is 2 cosecant u, just to make my life a little bit easier. So I've got the square root 4 cosecant squared u minus 4. So that's everything now in terms of u. So no x is in there at all. So I need some simplifications, and let's see what we can do from there. Well, straight away I've got minus 2 and 4. So that simplifies to minus 1/2. So if I was to rewrite my integral, I'll bring the minus 1/2 out, take those out. So that's taken care of those, so they're done. Cotangent u, so I'm going to leave that. So cotangent of u. My parameters, now I notice here I've got pi over 4 and pi over 3. Now pi over 3 is obviously slightly bigger than pi over 4. So that would give me a negative integral, but with this negative here, I can cancel them both out and then switch my parameters. So if I turn this into a plus, just for that, then I can put pi over 3 as my upper limit, pi over 4 as my lower limit. So pi over 3, pi over 4, there we go. Right, now here, cosecant u, cosecant squared u. So that will cancel out with one of those. So now I'll have cosecant u in my denominator. So cosecant u. Du will stay. Now this one, what have I got there? I've got square root. Now 4 is a square number. So I could take a 2 out of that. So I could rewrite this. If I just write this underneath, I've got 4. And then I'll have cosecant squared u minus 1. So I could bring a 2 out. So then let's put that in front here. And then cosecant squared u minus 1. Well, I've got a trig identity there. So let's write that over here. So I've got cosecant squared u minus 1. That gives me cotangent squared of u. So cotangent squared of u. So put that in its own little box so I don't mix it up with this. So I could substitute that for cotangent squared u. And it's multiplied by 4, so I've taken care of that. So that there is just cotangent squared u. And it's in a square root, so I can just write cotangent u. So then all I've got there now is cotangent of u. And this is all of a sudden starting to jump out and looking very simple. So I've got cotangent, cotangent, they cancel. So pi over 3, pi over 4. Cancel cosecant of u. Well, cosecant is just a reciprocal of sine, but this is in the denominator. So I can put sine in my numerator and that'll be just sine. So now I've got sine of u du. And now I just need to sort out my constant multiple. So I've got a 2 here and a half here. So I just put a quarter there. So that takes care of that. And now all of that, I'm just left with the integral of sine of u. So the integral of sine of u, nice, straightforward. So the integral of sine of u is negative. So it's negative 1/4 sine of u. That's going to give me cosine u. And then integrate that from pi over 3 to pi over 4. Okay. So now, what have I got now? So I've got minus 1/4 cosine of pi over 3 minus cosine of pi over 4. Okay, so cosine of pi over 3 with minus 1/4. Cosine of pi over 3. So cosine of pi over 3, that's going to give me a half. And cosine of pi over 4, that's √2 over 2. Okay, so that is our integral evaluated. Let's just simplify this up a little bit. So then that will equal, well, a half is smaller than √2 over 2. So I'm going to turn them around and change this minus to a plus. And then I bring this 2 outside. So then I've got 1/8. And then I have √2 minus 1. That there is the result of my integral. So I'm going to write this up here. So this then equals √2 minus 1 over 8. And that is the result of our integral using this substitution. Now, the other two options which you could try, I'll let you have a look at those and see if you get the same result as what I've got there. Okay.